Alright, here we go, ladies and gentlemen. We've already done this lesson, but I thought I'd throw the video up now anyway. So there's a full set of videos. Now 3.3 deals with factoring of polynomials, okay? We're going to get a little bit more complicated with these, but we're going to start off pretty simple. What I'd like to explain to you first of all is what the polynomials are, okay? So you may have heard of these three terms before, okay? A monomial, a binomial, a trinomial. And what we're looking at primarily is the prefix here. Mono, right, bi, and tri. What we're looking at here is, this is a one term, okay? This is two terms, and this is three terms. Now what I want you to understand is that these are all polynomials, and once we get to four terms, okay, then it's not a quadrinomial, or a cinconomial, or a sixonomial. These are the only three that have real specific names. They are, however, all polynomials. Okay, now what might not necessarily make sense to you yet either is the word term. Okay, what is a term? Well, a term is a number or a variable or a combo, and terms are separated by a plus or minus. So I could have something like 3x squared. That is a monomial. If I go plus 5x, boom, that's a binomial. If I go minus 2, boom, that's a trinomial. They're all polynomials, and what I can actually do is start putting ones in front of that too, with higher, what we call degrees, okay? And notice that each of these terms are split up with a plus or a minus. So technically, you could string the entire alphabet together with no plus or minus, and that would still be one term or a monomial, okay? So what we're also going to have to remember here is how to what we call expand these, okay? You've probably done this in grade 9. Well, I hope you have. And this is an expansion. It's called the distributive law. The distributive law, because you're distributing the two onto everything in the inside. Because I put arrows there, some people know it as what we call the arrow law, but what it basically means is that the 2 has to get multiplied by everything on the inside, right? So this ends up becoming, let's just slide it over here. Ding, 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 la, 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 making a mess, making a mess. Here we go. So this is going to be 2 bracket x plus 3, well, 2 times x gives you 2x, and 2 times 3 gives you 6. So that would be the answer to this, okay? 2x plus 6. Now in this case, what we have is boom, boom. So x times 2x is 2x squared, x times negative 1 minus x. Boom, you're done, okay? This one's a little bit more complicated, but hopefully you can still do it. Now when we have variables and numbers together, what you might find a lot easier is if you actually separate them, do the numbers, and then do the x's, and then do the y's. Do them separately, less daunting, a little bit easier, smaller steps, okay? So 3 times 5 is 15, right? X times x is x squared, y times, well there's no, so we're just going to leave it as y, minus 3 times 2 is 6, x, nothing else, y times y, y squared. Boom, there you go. This would be your solution or your expansion of that binomial there, okay? This is all called expanding, right? Some of you may recall doing 2 binomials like this, right? And what we have to remember here is that this x gets multiplied by both, and this 2 gets multiplied by both. So we have this thing called FOIL. I don't know if you've ever done this, okay, but this means the front 2. So in this case, it's x times x, which is x squared, right? And then the outside, right, would be x times 3, which is 3x. And then the inside, okay, would be 2 times x, so 2x. And then the last 2 would be 2 times 3, which is 6. And then we just put these together, right? X squared plus 5x plus 6. There you go. That would be that expansion, okay? Now, you don't necessarily have to do this all the time, but until you get the hang of it, or if you've got the hang of it, great, but you know what? It's not a bad idea. What I do, let me show you. I just go boom. That's x squared. That's plus 4x. That's minus 1x. And that's minus 4. And then whenever you do it this way, you're always going to have two terms in the middle that you need to combine. Group them together, right? Plus 4 minus 1 is plus 3x minus 4. Boom, you're done. That expansion is this. Okay, so these are expansions. These are just multiplying things out. What we are going to really look at today is going the other way, getting from this to this, getting from this to this, from, yeah, basically these. And then we're going to deal with the trinomials later. Those get a little bit more complicated. Okay, now what I'd like you to think about, first of all, too, is hopefully you can remember what a GCF is, right? So you have to recall your GCF. That's one thing. You have to recall or remember dividing monomials as well. Now you might not know exactly what I mean by that, but let's have a quick look. Okay, we're going to take this aside here, dividing monomials. So if I had something like 5x squared y over 10xy, do you think that you could reduce that? Right? Or actually, let's change it around here. Let's put the 10 on top and the 5 on the bottom. So again, this is what I'm talking about when you're breaking things up. Do the numbers separately. So the 10 over 5 becomes a 2. The x squared over x becomes just an x, and the y's cancel out. If you don't see why x squared over x becomes that, well, what you can do is break it down. X squared is x times x. Boom, you cancel one of them. You have one left on the top. Okay, this division of monomials is something that we're going to be doing when we're solving these factors or these binomials when we're factoring them. Okay, so what we're calling it GCF factoring, which means that we're looking for the GCF. Okay, we have to find the greatest common factor in this thing here, in these two terms. So the GCF for these two, what goes into 6 and 9? Well, it's going to be 3. How about n? Well, there's no n here, so you can't use n as your GCF. So what you do is you put your GCF on the outside and find out what's left in the brackets. And the way we do that is you divide by your GCF. So 6 over 3 is 2, and there's an n left, plus 9 over 3 is 3. There you go. You've gone backwards. You've gone from this to this. Okay, you've put it back in a factored form. If you wanted to check your answer, you simply multiply it out. 3 times 2n is 6n. 3 times 3 is 9. Boom, you're done. Okay. Let's look at a couple more here. They get a little bit more complicated. Not too bad. 8d squared and d. The difference is now we're going to be taking out a GCF that has a variable in it. So let's identify your GCF here. Okay, your GCF between 8 and 12, hopefully you'll see it's 4. If you can't find your GCF, we go through that whole process of prime factorization with the factor tree, okay? Then you look at the bottoms. Now, d squared and d, right? There's at least one d in each, so my GCF is 4d, and that comes out. And then what you do is you divide by your GCF. 8 divided by 4 is 2. D squared divided by d is d, plus 12 divided by 4 is 3. D's cancel, boom, there you go, you're done. Okay, now these don't get that much more difficult, really, they just get longer. Okay, now here is a situation where you have a trinomial that you're going to have to factor out. Notice that there's only a z in these two, so you can't take out a z, but we can see that my GCF between 6, 12, and 18, hopefully you can see that that is a 6. So the 6 comes out. Now, a big mistake here is people are going to think, well, I took a 6 out, I got nothing left. Well, if you actually do the process of dividing by your GCF, you'll see that this actually turns into a 1. You need something there to represent the fact that there was something there. 12 divided by 6 is 2, so it's a negative 2, and we'll leave the z there. Plus 18 over 6 is 3, and we'll put the z squared there. Boom, and you're done. Okay? I'm going to give you one last example here, and we're going to see if you can find the GCF, and I'm going to suggest to you another thing here as well. Okay, notice that they're all minus. Okay, so I think that it's going to be easier for you in the long run if you get used to factoring out a minus. Okay, so if you factor out a minus, you can see that the whole thing will change in the sense that all the signs change. And then that's plus 16x squared y squared, right? Those are exactly the same. Except these now are all positive. So Let's look between 12, 20, and 16. Hopefully you can find a, whoops, you're off the paper there, Dave. There we go. A 4, right? 3 x's, 1 x, 2 x's. There's at least 1 x in each case. Y squared, at least 1 y in each case. So my GCF is negative 4xy. So it's going to be negative 4xy onto, well, let's figure it out now, right? Yeah, so I took the negative out, so now I'm dealing with this, right? I put the 4xy in front, so it's going to be like this, negative 4xy now, so I took a 4xy out of these. Let's see what I have left. So dividing that by 4 is going to give me 3. X cubed over x is x squared. Y's cancel, I'm done with that. Plus, 4 goes into 20 5 times. The x's cancel, I have 1 y left. 4 goes into 16 4 times. I have 1 x left and 1 y left, and this is the final answer. So what I did here essentially, guys, let me just erase this part here. Right, I already took the negative out, so what I'm doing is dividing each of these by 4xy, because I already took the negative out. Okay, now if you want to do the negative before, you'd have to realize that you're dividing a negative by a negative, which would make it a positive. A couple of different ways to do this. Hopefully you'll get it sorted out. Okay, we're going to look at trinomials next. Have a nice day.